Hello everyone, this is Streamer and welcome to Genius Math Minds. In this video, we will be seeing about two topics that are HCF and LCM. Now let's start with HCF. Now the full form of HCF is highest common factor. Now what is this? What is highest common factor is? We know what a factor is. That is, let's say we have two numbers like 6 and 8. The factors of 6 are 1, 2, 3 and 6. These are the four tables that 6 will come across. For 1, 6 are 6, 2, 3s are 6, 3, 2s are 6, 6, 1s are 6. So these are the four tables 6 will come. Now for 8 it is 1, 2, 4 and 8. These are the four tables that 8 will come. So these are the factors of 6 and these are the factors of 8. So we have found out what the factors are. Now the common factor. What are the common factors here? The common factors are 1 and 2. That is, the common factors of both these are 1 and 2. So that is the common factor. Now the highest common factor, that is 1 is less than 2. So 2 is the highest common factor. So this is what HCF means. So the HCF of 6 and 8, HCF of 6 and 8 is 2. The another name of HCF is GCD. Both these means the same. So here GCD full form is greatest common divisor. So this is what HCF means. Now we will see the ways of finding the HCF of two numbers. Let's take numbers like 16 and 36. The first way of finding the HCF of a number is 16, the multiples of 16 is 2 times 2 times 2 times 2. This is what equals 16. But these should be prime factorization. That is, all these should be prime numbers. Now, we will do the same for 36. For 36, we will have 2 times 2 times 3 times 3. 4, 4 3s are 12, 12 3s are 36. So this is the way of factoring 36. Now what we will do is, that is the common terms. The common terms are 2, 2, 2 and 2. These are non-common terms, so we should not include those. So 2 times 2 is the common term. What is 2 times 2? It equals 4. So the HCF of 16 and 36 is 4. So this is one way of finding the HCF of two numbers. The another way of finding the HCF is by Euclid's division lemma. This is kind of like a way or a new thing found by Euclid. This is to find the quotients and remainder of two numbers. We can also use that to find HCF. So we will have the same two numbers here. What the formula is A equals BQ plus R. Now these are two numbers and this is the quotient of these two numbers and this is the remainder. So we will apply this for finding HCF. So the higher digit here is 36. So that will be the value of A. The lower digit is 16. So that will be the value of B. Now 36 divided by 16, we will get a quotient of 2 because 32. If we subtract, we get 4. So we have 2 plus 4 here. Now the next step is, this will become A and this will become B. So what we will do is 16 equals 4 of plus some remainder. 4 times 4 equals 16 and the remainder is 0. Here the number we got here. So what we should do is, at last, whether we get 0 or where we get 0, that is where we should stop this. So the B value when we get 0 is the HCF of these two numbers, that is 4. So the HCF of 16 and 36 is 4. So this is another way of finding the HCF. And another important thing about HCF is, let's say we have two numbers that have no common factors other than 1. Let's say we have a number like 16 and 19. These two numbers, the factors are only 1. The common factor is only 1. So the HCF of these two numbers is 1, which means these are called co-prime numbers. These two numbers are collectively called co-prime numbers. Let's say we have 19 equals 16 of 1 plus 3. Now 16 equals 3 of plus some remainder 3 of 5, we get 15 1. 3 equals 1. If we get 1 here, that is where we should stop, because if we keep doing this, then we will for sure get 0, because this is 1. So everything is divisible by 1. So we should stop here. If we get 1, we should stop there. So if it stops with 1, then the common factor or the highest common factor HCF will be equal to 1. Because the highest common factor is 1, there is no other number or no high number that both these will come in one table. So that is the thing with HCF. The next thing is LCM. The full form of LCM is least common multiple. Let's take, we have numbers like, let's take the same number 6 and 8. So the multiples of 6 we should write here: 6, 12, 18, 24, 30, and it goes on. And for 8 it is 8, 16, 24, 32 and 40, and it goes on. So what we have done is, we have found the multiples of 6 and 8 here. The common multiples are 24, and then if we add one more step here, we will have 48. So the common multiples of 6 and 8 are 24, 48, and it will go on. But what we are required to see is the least common multiple. So the least number we have here is actually 24. So the LCM of 6 and 8 is 24. So this is what LCM means. Now a method to find the LCM is, let's say we have the same numbers as we took for HCF, 16 and 36. So what we should do is, 16 equals the same thing we have to do for here also, the prime factorization. So this is what we got for prime factorization of both of these numbers. So what we should do is first find the common terms, just like what we did for HCF. So the common terms are 2 times 2. So this, if you just stop here, this will be the HCF of these two numbers. But for calculating the LCM, 2 times 2. So first what you should do is find the common terms. The common terms are just 2 times 2. So we have wrote that. The next step is write all the other things. That is 2 times 2 times 3 times 3. If we multiply all this, we will have the LCM of this. So 3 times 3, 9, 9 2s are 18, 18 2s are 36, 18 2s are 36, 36 2s are 72, 144. So the least common multiple of 16 and 36 is 144, which means this is the least number that comes under the multiples of these two numbers. So this is the way of finding LCM of two numbers. Now interesting thing is, we can also find HCF and LCM for both decimals as well as fractions. So for decimals, let's say we have number like 0.2 and 0.4. First we should remove these decimals. So we will have 2 and 4, that is multiply by 10 with both. So we'll have 2 and 4. The HCF of these two numbers is 2, as we can clearly see here. So what we should do is, as we multiplied with 10, at the last step after finding the HCF of these two numbers, we should divide it by 10. So we will get 0.2. So this is the HCF of these two numbers. Now for the LCM, 2 and 4, the LCM of these two numbers is 4. So again we should divide this, so we will have 0.4. This is the LCM of these two numbers. So this is the way of finding the HCF and LCM of two decimals. Now for two fractions it is much easier. If we have to find the HCF of a fraction like a by b and c by d and some fractions, what we should do is, since we have to find the HCF, what we should do is find the HCF of all the numbers, divide by LCM of the numbers. That is the HCF of the numerators, we have to keep it in the numerator, and we have to find the LCM of the denominator, so keep it in the denominator. So this, what the fraction will get at the last, is the HCF. Now if we should find the LCM, then just do the opposite. That is, take the LCM of numerator and keep it as numerator, and find the HCF of denominator and keep it as denominator. So this is the way of finding the HCF and LCM of two numbers. We can also do this with polynomials also. Just the same methods. So that's it with HCF and LCM. Thank you.